Hi guys, welcome back to Worms Maths Academy. We're about to run through the 2019 Exam 1. Just to let you know, I will be uploading Exam 2 at some stage, but I'd really like to get to 1,000 subscribers before then. So if you've got any friends and they want to check it out, ask them to subscribe and hopefully we'll get it up pretty quick. Okay, all questions must be, where a numerical answer is required, an exact answer must be given unless otherwise specified. More than one mark is available, you must show the work. Unless otherwise indicated, diagrams are not drawn to scale. Okay, so find the integral of this. Oh no, sorry, differentiate this. So first I would rewrite it. I'm using blue just because I know you have to use a pen instead of a pencil. So f of x is 3x minus 1 to the negative 1. Of course, we need to use a chain rule. So we bring out negative 1 down the front, multiply it by the derivative of the bracket, multiply it by the bracket, and subtract 1 from the power. So f dash of x is negative 3 on 3x minus 1 squared. Okay, find an antiderivative of f of x. Now I'm assuming this is why we've got this restricted domain, because it only wants the positive values. So we can say 3x minus 1. If we put a 3 on top, we've got to put a third out the front, dx. The top is the derivative of the bottom, so we know that our antiderivative is 1 on 3 log e of 3x minus 1. You don't need to put modular signs because it's only defined for 1/3 to infinity. Okay, evaluate g dash of 1. So let's do our working out. U is sine pi x. U dash, when we derive sine, we just get cos. So pi cos pi x. V is x plus 1. V dash is 1. Of course, when we derive this, we know V has to come first. So if we multiply these together, we get x plus 1 times pi cos pi x minus sine pi x on V, which is, V squared, x plus 1 squared. So g dash of 1, 2 pi. What's cos of pi? Cos of pi is negative 1. Sine of pi is 0. All on, when we sub 1 into that, we're going to get 2 squared, which is 4. So we get negative 2 pi on 4, which is negative pi on 2. Not a bad start. Still going with the same question, except this time it's defined for all values except for the denominator. So find the rule of f inverse of x. Let y equal 1 on 3x minus 1. Let y equal f of x. Swap x and y. So we get y is equal to 1. Sorry, I didn't swap them. 3y minus 1. When we switch these, we get 3y minus 1 is equal to 1 on x. And then we get f inverse of x is equal to 1 on 3x. That's going to become plus 1, and then I've got to divide it by 3. So plus 1/3. And of course, our domain, well, we can have any real number except for 0. So, they've called another function f of x. Okay, the domain of f inverse x is an element of all reals with the exception of 0, because you can't divide by 0. Let g be the function obtained by applying the transformation to the function f, where c and d are 0. Find the values of c and d, given that g equals f inverse of x. What? Find the values of C and D given. Okay, so we start with the original function, and we want to end up with f inverse of x, and we call that g of x. So, what do we need to do here? We've got the original function, y equals 1 on 3x minus 1, and that becomes 1 on 3x plus 3. Okay, so what do we want to do here? We want to becomes g is equal to f inverse of x, where g be the function obtained by applying the transformation t to f. So we want to get rid of that 1. So we're going to have to put in f of x plus 1/3, because if we sub that in, we get 3 times x plus 1/3, which is, what did I just do? 3 times 1 on 3x x plus 1/3 minus 1. So we get 3x plus 1 minus 1, which makes that disappear. So we've got to replace it with x plus 1/3. So that translates it 3 units to the left, 1/3 of a unit to the left. So we get negative 1/3. And then we've got to translate it up 1/3. So d is equal to 1/3. So all I did was look and see what transformations I needed to do to get it to move. Okay, the only possible outcomes when a coin is tossed are head or tail. When an unbiased coin is tossed, the probability of tossing a head is the same as, okay, Joe has 3 coins in her pocket, 2 are unbiased and 1 is biased. When the biased coin is tossed, the probability of getting a head is that. Select a coin from her pocket and tosses it. So we've got biased and unbiased. There's a 1/3, 2/3. This one, I should say, biased not. Head, tail, head, tail. So if it's unbiased, it's a 1/2 and a 1/2. If it's biased, head is 1/3, tail is 2/3. We want to work out the probability of getting a head. So that is the probability of biased and a head plus the probability of unbiased and a head. Biased and a head is 1/9. Unbiased and a head is 1/3. If we add them together, we get 4/9. Find the probability that she selected an unbiased coin given that she tossed a head. Probability that it's unbiased given that she tossed a head, which is unbiased and a head, over the probability of a head. We know that unbiased and a head is 1/3, or 3/9, over a head, which is 4/9. So therefore it is 3/4. Not too bad so far. Okay, solve this function. So if we take the cos x on 2 across first, we get 2 cos x on 2, then divide the x on the 2 to the other side. Cos of x on 2 is equal to 1/2, 1 to root 3. Of course, we know cos inverse of a 1/2 is, so you can say our base angle is pi on 3. A little bit stupid today. Okay, so we get x on 2. Now, because we're going from negative pi to pi, we've got to get when cos is positive. So negative 5 pi on 3, negative pi on 3, and pi on 3. Now, because we're going to double everything, this answer is going to get pushed out. So we don't need that one. So negative pi on 3 and pi on 3. So therefore, x equals negative 2 pi on 3 and 2 pi on 3. Okay, there's the function as shown. Does that look right? There's pi on 3s. There's a half. Negative 2 pi on 3. 2 pi on 3. So I think we got that one right. Okay, sketch the graph of g on the axis above. G is 1 minus f of x. So it's been translated up 1 and then reflected. Label all the points of intersection g of f and the endpoints. Okay, so if we reflect it first and translate it up, we get this point here. That's going to go up, reflect that, and then it's got to go up, reflect. That's going to stay there and then go up. So looks like that. Okay, so negative 2 pi 2. At a guess, they want us to get this, negative 2 pi on 3, 1/2. And what do we have to? Points of intersection of the graph f and g, the endpoints of g with their coordinates. 2 pi on 3, 1/2, and pi 1. Pretty sure that's everything. That's the origin as well. Yeah, if you have a look up there, you can see that 1 minus f of x gives us the same solutions. Okay, there's our function, f negative 1. So f of negative 1 is 2 on minus 1 squared plus 1. That's going to be 2 on 4 plus 1, which is 3 on 2. Not too bad so far. Sketch the graph labeling asymptotes. Okay, it's been translated up 1 and 1 unit to the right. X is 1. It's been dilated by factor 2. One, idiot. So it's been dilated by factor 2. It's going to go through 2, 3, and 0, 3. If you put negative 1 into it, what do we know that is? 3 on 2, negative 1, 1.5. Okay. So now it's going to look something like this. Oops, that was bad. Go up. It's going to approach that. 0, 3. It's got to be symmetric. So this should look the same. I don't know why this don't know what this iPad's playing up lately. Might be time to get a new one. We don't have to put this on, but I'm just doing it for my own sake. The area bounded by the graph of f, the x-axis, the line x equals negative 1, and the line x equals 0. So this area in here. If you wanted to, you could go from 2 to 3. Just by symmetry, which I'm going to do. 2 to 3 of 2 on, I'm going to rewrite it as 2x minus 1 to the negative 2 plus 1 dx. Okay, if we add 1 to the power, well, what are we going to get? We're going to get negative 1. So we get negative 2 x minus 1 to the negative 1, which I'm just going to write as negative 2 on x minus 1 plus x between 3 and 2. So that's by symmetry. Okay, so what do we get? We get negative 1, because if we put 3 into that, we're going to get negative 1, plus 3, minus, we're going to get negative 2, plus 2, which is 2 square units. Okay, so up to, that's 5 marks. Okay, Fred owns a company that produces pegs each day. He randomly selects 41 pegs that are produced on one day and finds 8 faulty pegs. The proportion of faulty pegs, P hat, is 8 on 41. Pegs are packed each day in boxes. Each box holds 12 pegs. Let P hat be the random variable that represents the proportion of faulty pegs in pegs. The actual proportion of faulty pegs produced by the company is 1 on 6. So P hat is equal to 1 on 6. And if we've got N is 12, we know that P hat is X on N. So X is equal to 12 times 1/6, which is 2. Find the probability that P hat is less than 1/6. That's the same as the probability that X is less than 2. Okay. Now, is this binomial or is it? Okay, faulty peg. So the actual proportion, so that's from the whole population. So this is binomial. So we'll say X is binomial with 12 and 1/6. So the probability that X is less than 2 is equal to the probability that X is equal to 0 plus the probability that X is equal to 1. So 0, 12, choose 0, 1/6 to the 0, 5/6 to the 12, plus 12, choose 1, 1/6 to the that's a 0, 1/6 to the 1, 5/6 to the 11. So here we've got 5 on 6 to the 12 plus 12 times 1 on 6, which is 2, times 5 on 6 to the 11. Okay, so we can take out 5 on 6 to the power of 12. 11, sorry. So we're left with 5 on 6 plus 12 on 6, which is 17 on 6. I could just write it, they want to rub out your stupid thing. 17 on 6, 5 on 6 to the 11, which is, hopefully it is in that form. N is a positive integer, yep, that all looks good. Okay, the graph of the relation root 1 minus x squared is shown. P is the point of the graph of the relation. A is that, that's that. So we can really say that P is x root 1 minus x squared. Find expression for the length PB in terms of x only. Well, PB, that's just root 1 minus x squared. So the length PB, 1 minus x squared. Find the maximum area of the triangle APB. So our area is a half times our base length, which is x minus minus 1, so it's x plus 1, times our height, which is 1 minus x squared to the power of a half. Probably the easiest thing to do here is to write x plus 1 on 2 times 1 minus x squared to the half. So dA dx is, derive the first thing, we get a half, leave the second thing alone, root 1 minus x squared. Derive the second thing, we get a half times negative 2x, the derivative of the bracket, times 1 minus x squared to the negative a half. And then of course we've got to multiply that by x plus 1 on 2. Okay, so let's have a look at what we've got. We have got root 1 minus x squared on 2. That cancels with that. So on the bottom we've got a 2, so plus 2 root 1 minus x squared. That's that done, and then I've got x plus 1. Okay, so let's get on with the common denominator. If we do that, on top we get 1 minus x squared, because if I multiply that by root 1 minus x squared, it just becomes 1 minus x squared. 2 plus 2 root 1 minus x squared plus x squared plus x. So we end up with that doesn't look right, does it? Why is that wrong? X squared plus x, 1 minus x. There it is, that negative there. I'm like, it can't be right. So I've got negative. It couldn't be negative 1, because that would produce no error. Okay, so that's negative, then this will become negative x squared minus x. Okay, so we get negative 2x squared minus x plus 1 on 2 root 1 minus x squared. If we let that equal 0 for our max, so we get 2x squared plus x minus 1 is 0, 2x minus 1, x plus 1, x equals 1/2 or minus 1. Minus 1 is a min. Find the area. Okay, so therefore, area is, I'm going to put a half into this. 1/2 times 3 on 2. Because when I put a half into that, 1 minus a half squared, which is 3/4, square rooted. So what do we end up with? 2 on the bottom, so 8, 3 root 3 on 8 square units. It seems right. How many questions is there? Quite a few. Okay, function polynomial degree 4, part of the graph is shown, touches the x-axis. Find the rule of f of x. Okay, it's got a turning point at 0, 0. That's repeated. X squared, x minus 1, x plus 1. If I let x equal 1, if I get 1 on root 2, 1 on root 2, we get 1/2. Which point can we use to work out what a is? Because we need some sort of dilation factor. So f of x is a, x squared, and we got 1 equals a times 1/2, 1 on root 2 minus 1, 1 on root 2 plus 1 is a half minus 1. We could change this to be, it's easier if we use x squared minus 1. So that's why it's a half minus 1. And we're going to get negative 1/4, so a equals negative 4. Does that make sense? Because we know if we had x plus 1 and x minus 1, that's x squared minus 1. And when we sub 1 on root 2 into that, it just makes it a half. Okay, so therefore, f of x is negative 4x squared x squared minus 1. Let g be the function with the same rule as f. Let h equal that log e of gx. State the maximal domain. Okay, so we know that that function has to be greater than 0. And we also know that this function has to be greater than 0. Okay, and we know from negative 1 that's negative 1 to 0, or 0 to 1. This one here, if we take out x squared, we've got x plus 1, x squared, x plus 1. So if we sketch that, we've got a turning point at 0, and then we've got an intercept at -1. So an intercept at -1. Okay, so it looks like our maximal domain, if these two intersect, it can be everything except for 0 from -1 to 1. So we say x is an element of, we could just say -1 to 0 or 0 to 1. I could also say -1 to 1, not including 0. I should say D maybe. State the range of H. Okay, so the x values that go into here, we know the x values that come out of the x values that go into the first log. Oh, let's have a look. If I've got log e of, what was it, -4 x squared minus 1, because it's minus, we can change this to be x squared x plus 1, which we know this can be written as x plus 1 x minus 1, which means that cancels, so we get -4x minus 1. Okay, and into this, -4 x minus 1. Okay, so h of x is log e -4 x minus 1, and our domain is x is an element of -1 to 0, and then 0 to 1. Okay, so if we put -1 into it, we would get 0. If I put 0 into it, we would get log e of 4. So it can't equal log e4 because that endpoint's not defined. Alright, so if we put -1 in, h of -1 is log e of -4 times -2, which is 8. If we put h of 1 in, that's going to be undefined. So it's either going to go to infinity or -infinity. What am I doing? Let's just sketch it. Oh no, because that's the negative log. Okay, so we've got log E8. That's the first one. That's our maximum value. When it's 0, we get log E of 4. So it can't equal log E4. And then if we put 1 in, we get log E of -4 times 0. So that'll be -infinity. Okay, so our range, hx, is an element. Our lowest value is -infinity. Our highest value is log E8, which also isn't included because it's got a round bracket. and we can't have log e of 4 because it's undefined for when x equals 0, which gives us log e of 4. So it's from negative infinity to log e8 with the exception of log e4. Okay, state the rule of g of f of x. Alright, so g of f of x, that's going to be g of f of x equals e to the 3 plus 2x minus x squared. Find the values of x where the derivative of g of f of x is negative. Okay, so g of f of x dash d dx, I'm going to say instead of the other one because I hate trying to write the dashes correctly. So there's a bracket, there's another bracket. So we get negative 2x because we bring our power down the front, plus 2 e to the negative x squared. Derivative is negative. Plus 2x minus x squared. So this is always going to be positive because it's an e to the x graph. Doesn't matter what the power is, it's always going to be positive. So therefore to be negative, this has to be negative, the coefficient, so negative 2x plus 2 has to be less than 0. Negative 2x has to be less than negative 2. X has to be greater than 1. State the rule of f of g of x. So f of g of x is 3 plus 2 x, which is e to the x, and then minus e to the 2x. So negative e to the 2x plus 2e to the x plus 3 equals 0. Take out a negative. E to the 2x minus 2e to the x minus 3 is equal to 0. Factorize it. E to the x minus 3 plus 1 equals 0. E to the x equals negative 1. E to the x equals 3. X equals log e of 3. This one has no solution as e to the x is greater than 0 for all x. Okay. How long have we got? We're nearly there. I can get this stupid bloody thing to move. Find the coordinates of the stationary points of f of g of x. So, f of g of x is equal to negative e to the 2x plus 2e to the x plus 3. Sorry for the scrolling, but I kind of have to do it. So d dx of f of g of x is negative 2e to the 2x plus 2e to the x, which is 2e to the x (1 minus e to the x). That looks good to me. Equals 0. 2e to the x equals 0. 1 minus e to the x equals 0. No solution, as 2e to the x is greater than 0 for all x. E to the x is equal to 1. X must therefore equal 0. Find the coordinates when x equals 0. Actually, I can just write it. 0, stationary point. If we put 0 into that, we get -1 plus 2 plus 3, which is +4. State the number of solutions. State the number of solutions to g of f of x and f of g of x equals 0. Okay, so I've got a stationary point at 0, 4. We've got e to the 3 plus 2x plus x squared. I've only got one stationary point with the first one. F of g of x. So it's got a negative gradient. G of f of x has got a negative gradient from 1 onwards. No, is it 1 onwards? When x is greater than 1, we've got a negative. Okay, so from this we could say g of f of x equals negative f of g of x, or vice versa. So if we've got negative f of g of x we just did, that's got a stationary point at 0, 4. So the negative of it's going to have a stationary point at 0, -4. Do we know anything else? What will that graph approach? What is it? Negative e to the... that's going to approach -3. Just because we know that this, as x goes to infinity, it's going to approach 3 on that side. What else did we find out? What is the gradient? That's the other one. When x is greater than 1, this has a negative gradient. So when x equals 1, it's going to have, so it's got to be positive here, then negative here. Is there any limiting factor? E, so that's always going to be greater than 0. So we know it's got to go up like that, down like that, because it's got a turning point there and it doesn't turn back up. And what's the other one? So negative e to the 2x plus e to the x. We said it's got a stationary point at 0, -4, so that's got to go back up. And it doesn't turn back around. Is that bound? As x goes to infinity, we're going to get negative e to infinity, which is really negative. Then we're going to get plus 2e to infinity, which means it's going to go to infinity. So that graph's going to go up to infinity. So, by the looks of it, the number of solutions, there's one solution. There. Hopefully that's right. Don't know how everyone's expected to draw those. I think it's a bit hard for methods. So don't forget to like, share, subscribe. Get your friends to subscribe, and hopefully I'll put the other ones up tomorrow. Hopefully my answers are right. Not too sure. That was the first crack I had at it, so yeah, I've only really just seen it. Everyone keeps asking me what it's like, and I was like, I haven't really seen it yet. Okay, hope you did well. Bye.